Dear students, good morning. Welcome to our session today. The last video we have discussed about up to the fourth point, that is perceptron learning, before the perceptron learning algorithm. And this video we are going to see about perceptron learning algorithm overview. That is algorithm. In the algorithm we have the two-step process. In that first you have to initialize weight. Yes, obviously we all knew that whatever may be the condition, first step we have to initialize the weight to a small random values, right? And coming to the second one, for each training sample we have the three-step process. The first, compute the output using the current weight and calculate the error. How we can calculate the error? The difference between actual and predicted value. Okay. And coming to the third point, update weights using the formula. So these are the three-step process for each training sample we used to follow, right? And coming to the convergence, we knew that the algorithm iterates until the weight converge or a maximum number of iteration is reached. Yes, the previous video itself we have discussed about what is iteration. Iteration is a repetition process. For what purpose we are making the iteration? If we do the iteration, we can have the maximum possible output. For that purpose we are doing the iteration process. So I already mentioned with the example also, we have the a part and b part, and we need a c part. And what about the combination of an A and B, whether it may be 70-30 or 50-40? Likewise, first we will get the output as C, and we will verify whether the output is satisfied or not. If the outcome is not okay, then we need to do the iterative process with A and B. Okay, like if it is 70-30, we need to make it as 60-40 or 50-50. Likewise, we can adjust the weight space, also the bias mode, so that it will be iterated and we will can get the maximum convergence. So that is the concept here, convergence. The algorithm iterates until the weight converge or a maximum number of iteration is reached, right? And coming to the next, that is multi-layer perceptron. We repeatedly discussed about the what is perceptron, what is single layer perceptron, and multi-layer perceptron. Here the definition again we are recalling here. And multi-layer perceptron is a neural network with one or more hidden layers between the input and output layers. Is coming to the structure. In structure we used to have the three part. One is input layer, another one is hidden layer, and it is output layer. Is input layer, it receives the initial data. Hidden layers perform intermediate computations and features. For what purpose hidden layer? In hidden layer we can have the many number of layers, either layer 1 or layer 2 and so on. Okay, based upon the complexity of the solution or problem, the hidden layer will be increased. Okay, and for what cause we have perform intermediate computations and feature extraction. And coming to the output layer, it produces the final prediction. And next, activation function. Common functions include sigmoid and a rectified linear unit, that is RLU. And the so here the application we can have the multi-layer perceptron can solve more complex problems than single layer perceptron, including non-linearly separable problems. And back propagation, yeah, I already discussed what is propagation. Something we need to propagate, that is make a travel and breakthrough likewise. Okay, so back propagation, how to go back and reiterate the process and how to move forward again, that is called back propagation. Definition, technically we can have the overview here. Back propagation is an algorithm used to train MLP by adjusting weight based on the error gradient. And coming to the process, we have the forward pass and error calculation. Compute the output for each sample. Error calculation, measure the difference between predicted and actual values. Optimization, the process continues until the last function converge or predefined number of iteration is reached. These cases already we have discussed numerously. Okay, and coming to the overview of dimensionality reduction, that the last part we have here. And what is dimensionality reduction? The definition: the dimensionality reduction technique reduce the number of features in a data set while preserving as much information as possible. And the common technique, that is principal component analysis, projects data onto a lower dimensional space by finding principal components, the directions of maximum variations, we can say, right? And useful for visualization and noise reduction. This PCA is mainly useful for visualization and noise reduction. And T distributors, stochastic neighbor embedding, and maps high dimensional data to a low dimensional spaces. Obviously, the dimensionality reduction plays in this role, that is what high dimensional data. So we have the high dimensional data, we have to fit it into the low dimensional space. That is the main agenda of this dimensionality reduction, so that the cost of the function is going to be reduced and accuracy and efficiency will be improvised. Okay, effective for visualizing the clusters complex patterns. We all knew what is cluster, group of nodes or group of patterns. We can call it as a clusters. And benefits, it reduces the computational complexity, helps in improving model performance and visualization. So this is how the overview of the overall neurons and neural networks it is to be. And in this video still now we have discussed about that is what is perceptron learning algorithm, and each training sample how it could be, and what is convergence. And coming to the multi-layer perceptron, again what is definition, structure. In this structure we used to have the input layer, hidden layer, output layer, and activation, function, application. And coming to the back propagation, it is the definition, process, forward pass, error calculation, optimization. And the overview, here we have the dimensionality reduction. And the dimensionality reduction, what is the definition of it, and what are the technique used to have the principal component analysis, and TSNE also. But we used to have the principal component analysis, most common applications for to solve the complex problems. Okay, and benefits, reduce the computational complexity, helps in improving model performance and visualization. Thank you for your passion listening.